Okay, so we're talking about a limiting reactant example now. So we're going to do an example. In nature, as you know, as we just read in the textbook, in nature, there's not exactly the exact right amount of moles of this ratio to this ratio, and everything's going to be all perfectly efficient, and there's going to be nothing left over. That's not the way it works. There's lots of everything. There's usually one thing, that's the limiting reactant. It runs out first, and so the rest of the equation, their chemical reaction, stops. So this question says, find the limiting reactant when 2.8 moles of nitrogen burns in 9.22 moles of oxygen to produce nitrogen dioxide. Okay, so before you get going too far and just look at these numbers right here, you can't just say that, oh, this one's smaller than this one, so this one's the limiting reactant. It's going to get run out first. Yeah, you don't know that for sure. It might be true, but you have to write the equation, you have to balance it properly, and then you have to do our steps to finding the limiting reactant. So let's write the properly written chemical equation. So nitrogen burns in oxygen. Remember, nitrogen is part of the diatomic 7, so it's going to be N2. Burning in oxygen is simply plus O2. And we're going to produce nitrogen dioxide. So nitrogen dioxide, di is 2. Okay? So we have N2 plus O2 equals NO2. Now, problem here, this is not balanced. I've got two N's and one N, so I got to put that there. And it looks like I got to put that there. Then we're okay. All right, you see that? So we got two nitrogens, and so on. 4 oxygens, 4 oxygens. We're good. All right, so now we do this. And I would suggest, again, just like we did with stoichiometry before, 2.8 moles of nitrogen. So put the 2.8 moles here. It's good that we have moles. We don't have to do any conversions to begin with. If we had grams or liters or particles, we would have to convert to moles first, right? That's part of our steps. And here are the steps. The steps are right here above. We just went over these, right? Convert all quantities to moles. We're actually given moles of this one. And we're given moles of this one too. So watch this, 9.22. Okay, moles of oxygen. So which one is the limiting reactant? Well, it could be the smaller one, but notice we do need double the amount of moles because it's a 1-to-2 ratio. So sometimes it's not as easy just as looking at the numbers of moles. This might turn out to be what you guessed, but let's check it out. So I'm going to divide this by what? By the coefficient in the balanced equation. Divided by 1, I get 2.8. I'm going to take this number of moles and divide it by this coefficient. Divided by 2. What's that going to be? 4.61? 4.61 moles. Hopefully I've done that correctly in my head. Now, why do we do that? Well, this is just part of our way of calculating the limiting reactant or determining the limiting reactant. Divide the moles of each quantity by its coefficient. The smaller number here is going to be the limiting reactant. And of course, 2.8 is smaller than 4.1. So guess what? N2 is the limiting reactant, okay? Or limiting reagent. You might call it limiting reagent as well. So that's great. Now, knowing that, I can now get rid of this little calculation determination, okay? I can get rid of that. And I also do this. I obviously am going to have extra O2, so there's going to be excess here, see? There's going to be extra. Why? Because I need 2.8 of this. I'm going to use that all up, and 2.8 times 2 over 1 is going to be what? 5.6. So I need you to see there's two things you can determine. A, the limiting reactant is nitrogen, and we've shown that. And this question actually only asks us for determining the limiting reactant. So N2, limiting reactant, you just leave your work there, you're done. But if the question also says, there's another question that could be asked, how much of the excess reactant is left over after a reaction happens? So that's when you say, oh, well, this is my excess right here, the O2, and I've got 9.22, and I'm only going to need 5.6. So how much is left over? The difference between 9.22 and 5.6. So you do 9.22 minus 5.6. Okay, so we've talked about it, we may as well do it. So 9.22 minus 5.6, and you can do that in your head or on your calculator, I don't mind. I'm going to do this on my calculator so I don't mess up for you. Minus 5.6. is going to be 3.62. 3.62, and that's moles. So that says moles of excess O2 that is unreacted here. Okay, so there's another thing you can determine. Now you can go ahead, if you want, if you're asked to in another type question, you can find out now how many moles of NO2 you should get. Well, this is not true anymore. We don't focus on this one. We focus on the limiting reactant. And I can use now this number with the molar ratio times 2 divided by 1. So 5.6 moles here of NO2 is going to be produced. 5.6 moles of oxygen is required to react with this, and so on. So find the limiting reactant, and then that unlocks all of the rest of the stoichiometry. So when you're given two amounts of reactants, so you're given some reactant A, reactant B, you have to find the limiting reactant first and determine which one that is. Okay, so I'll do some more examples with you in a bit.